Hello and welcome to Week 1, Unit 3 of the Open SAP course, Touch IoT with SAP Leonardo. Now that you've seen some examples of what's possible with the Internet of Good Things, it's time to take a closer look at how the Internet of Things works, especially in the context of sensors, connectivity, and insights. So let's get started. Sometimes the Internet of Things is referred to as the Internet of Everything. And the reason for this is because experts predict that the importance of sensors is going to continue growing even more in the future to the point where nearly everything will be or will have the potential to be connected. It's estimated that there will be up to 100 trillion sensors by 2030. And the speed of analytics will grow 30-fold by then, with 95% of queries answered in milliseconds. And around the same time, image, speech, and voice recognition will get to a point where it's nearly 100% accurate. Just taking a snapshot of what things will look like as soon as 2020, sensors will be commonplace in the 111 new cars and the 2 billion smartphones that will be purchased that year. So this is a market that's expected to grow into the tens of trillions of dollars. So, keeping that in mind, let's look at the key components involved in the Internet of Things. Here's a simplified version, including what we call a device layer, gateways, backend systems, and an application layer. So in or on the device, a sensor detects a certain event and then transmits this data either directly to backend systems or transfers this data via a gateway. So gateways are communication devices that are needed for sensors that cannot connect directly to backend systems. Next, the backend systems process the data and connect them with other business data. So backend systems typically contain enterprise resource planning systems, also known as ERP, which basically run the day-to-day of a business. And backend systems can also contain IoT platforms to process IoT sensor data. And it's important to note that I'm using this term backend systems somewhat liberally. These various backend systems for business data and sensor data, they're often running in the cloud, meaning in a data center not necessarily central to where the business itself is located. Or these systems can also be running on-premise, meaning on systems located exactly where the business itself is located. So once the business data and the sensor data are combined wherever they are, the application layer can analyze the data from the backend systems and based on the result, a corresponding action can be initiated. So to illustrate this process, let's have a look at the different building blocks of the Internet of Things in even more detail. This is going to help us understand how they all fit together. So let's start with sensors, because sensors are a fundamental element of the Internet of Things. What exactly is a sensor? A sensor is a small device and it identifies information from its physical surrounding. And technically, a sensor device is a transducer with two layers. A sensor layer to measure the actual value, like voltage changes, and then a signal condition to convert the measurement into meaningful information, like temperature changes. If the sensor detects a change in the environment, then it generates a corresponding action through either recording, indicating, or responding to that change. To clarify the use of sensors, let's look at a practical example from everyday life. Imagine you own a smart refrigerator. This fridge is equipped with a temperature sensor, and the sensor surveys its environment to ensure that the desired temperature is constantly held. And this is in order for the goods in the fridge to remain cold and fresh. If the temperature suddenly rises, the sensor detects the increase. And as a result, it generates a signal to transmit this information. And then this signal could, for example, trigger an alert. It could trigger an alert to induce a certain action. Various types of sensors are used to detect conditional changes in many different settings. And these are just a few examples listed here. You've probably been in contact with many of these and quite possibly some that aren't listed here. There's a lot of them. But a sensor would not be useful without connectivity and without the ability to transmit data to the backend systems. So now that we've reviewed some fundamental information on sensors, let's look at different types of sensor technologies. So let's start with Wi-Fi technology, which can be used to track people or things in a particular area. For example, a person's location can be determined by pinging the address of mobile devices such as smartphones. Bluetooth or Bluetooth Low Energy, sometimes called BLE, it's used to connect sensors to mobile phone applications. For example, in the context of fitness trackers, you might have a device you wear on your body that uses sensors to track your footsteps, and then what would happen is Bluetooth would connect this device to your mobile phone applications. RFID, on the other hand, standing for radio frequency identification, it's an automatic data capture technology that uses radio frequency waves to read a movable item. This technology is often useful in settings involving asset management and supply chain operations. Now, to understand connectivity, let's take a look at a diagram of the components of a typical sensor device, including the connectivity layers. As we discussed earlier, the device has sensors, and these sensors are programmed to send signals to the device processors. The device processors will process the raw signal and then send the process data to the emitter. The device emitter will package the process data as messages using standard message types like JSON or XML. And then the emitter will send the message to remote or local systems using HTTP or MQTT, which is a lightweight messaging protocol for small sensors and mobile devices. And then the sensor device connects with these systems via standard connectivity methods like Bluetooth, Bluetooth Low Energy, 4G, 2G, and others. And finally, the sensor device needs some security and configuration components to enable different security settings. So a directly connected sensor can connect to the back-end systems and send data by using high-speed internet. These types of sensors are the ones based on Wi-Fi, 2G, 3G, 4G, LTE, and other standard communication technologies. For these types of sensors, a gateway layer is not required, but frequently sensor devices do not have communication capabilities to transmit all their sensor data in a secure, reliable, and cost-efficient manner to the back-end systems. So what this means is a locally connected sensor relies on nearby gateways, smartphones, or other means to deliver messages to back-end systems. And these sensors are typically based on some form of Bluetooth or other communication technologies. And in this case, a gateway layer is required. So a gateway, it connects and receives data from locally connected sensors via communication protocols like low energy Bluetooth or Zigbee. And at the same time, a gateway also connects to backend systems directly and sends sensor data using high-speed internet. So let's now review the topic of insights that businesses can derive from the backend systems layer combined with the application layer. After you're done reviewing the basics of sensors and connectivity layers, it's really time to look exactly at what we can do with this data in the context of how it flows through each of these steps. So first, the data will be transmitted to the backend systems. Companies use backend systems like customer relationship management or CRM, human capital management or HCM, and supply chain management or SCM. And they use all these different systems to run their business. Backend systems using IoT platforms process sensor data and then map this sensor data to existing master data for the devices. Additionally, backend systems contain existing business data to define business rules and processes. Backend systems also have a repository of historical data. So then second, an IoT application will use this combined data to provide features like the following: monitoring of devices equipped with sensors, sending of notifications based on business or device status rules, and then also analysis of the data, and it's sometimes combined with other data for deeper insights. Finally, the user of the application will use those insights to take actions and improve the business. So let's take a look at some basic examples of insights. So here's an example of a coffee company that has hundreds of thousands of coffee machines potentially installed in both public and private places. The company would like to get insight on device status and usage. So the company can work with vendors to install all the necessary components, starting with the device layer by installing sensors on the coffee machines. And then they would connect them with backend systems, and then finally analyze the data in a packaged IoT application. So this visualization here depicts what insights an IoT application can provide for each machine. Insights derived from the real-time working status of the machine combined with the master data of the machine. Think of this as real-time trending data of coffee consumption or usage insights, stock level or inventory insights, and brew temperature or quality insights. And this is just a super quick snapshot of a few options. You're going to learn a lot more in future units of what else is possible when using this approach of combining data to derive insights. But for now, let me just leave you with one more hypothetical scenario of an IoT application analytics set of features. And this is meant to show you how this can provide this coffee company with deeper insights. Because of the availability of master data, like coffee bean brands used in the machine or location of the machine, that data can be aggregated and then used for valuable analysis. So in this example, you can see that the analysis shows the top 5 coffee brands by region, and you can notice that the brand Manhattan Special is a very popular brand, especially in the East region. But then the brand Costa Coffee, it looks like it's doing poorly in the East region. And so with that, we've completed our discussion of the key components involved in the Internet of Things. And just by way of recap, this includes the device layer, gateway, backend systems, and the application layer. And next up, Lisa is going to take us on a journey of exploring other innovative technologies which are impacting the Internet of Things. So thanks for joining and enjoy the rest of the course.